So today we're going to cover section 8, and this is going to cover spheres. So let's go ahead and see what a sphere is. So a sphere is the set of all points in space equidistant from a given point. So that given point will be your center. Now, for the spheres, the only value you're going to be given is either a radius or a diameter. When you're dealing with a sphere, we don't have a side length, okay, because it's circular in shape. So examples of a sphere could be like a globe or a basketball. So remember, you'll be given either the radius or the diameter and the formulas all use radius. So if they give you a diameter, you're going to need to turn it into a radius by dividing by 2. Pretty good so far? Okay. All right. So down here, before we talked about like cross sections at the beginning of the chapter. So if we were to slice a sphere in half by slicing it with a plane and you lift it up, the shape that you would see would be a circle. Now, if we were to slice this sphere right in the middle, an example could be like the globe or the world. And the slice would occur at the equator, and then it would create 2 hemispheres. So it would split it into 2 separate hemispheres. This circle that occurs right here, like if it were the world at the equator, is called the great circle that's created. So if you were to pick it up and lift it up. Next slide. Here is the formula for surface area of a sphere. Now, we don't have lateral area. All we have is surface area, and it's 4 times pi r squared, again, where r is the radius of the circle. So again, if you've got your formula sheet and you want to add it to it, we're going to have a quiz next week on lessons 4.8 and 4.9. So you're going to need to know the surface area and the volume of a sphere for next week. Pretty good on the surface area formula. Okay, let's now do the volume formula. So here, the volume of a sphere is 4/3 pi r cubed. So what's different here is instead of 1/3, we've got 4/3. And instead of the radius being squared, now we're cubing the radius. So 2 more formulas to add to your formula sheet. And next slide, we're actually going to do some examples using these 2 formulas. So let's fill in the chart. Now, when we're filling in this chart, we're going to leave everything in terms of pi. So let me go ahead and write the formula up here. So again, remember for area of a sphere or surface area, it's 4 pi r squared. For volume, it's the 4/3 pi r cubed. So we're going to fill in the chart. So again, to change a diameter into a radius, we divide it by 2. And now I'm going to plug in the radius into this formula. So area equals 4 times pi times 6 squared. So 4 pi times 36. And I end up, left in terms of pi, 4 times 36 is 144 pi units squared, because they didn't give me centimeters or inches or anything like that. So again, remember, for area, surface area, the units are always squared. Now for the volume, we're going to do 4/3 pi times 6 cubed. 6 cubed is 216. I can simplify for the 3 and the 216. 3 actually goes into 216 72 times. And then now I'll multiply it. 4 times 72 gives me 288 pi, and these are units cubed. Volume is always to the third power. Let's try the next one. This time they gave me a radius. So to change it into a diameter, I'm going to times it by 2. So the diameter is 14. However, remember, the formulas all use radius. So now to find the area, I'm going to do 4 times pi times 7 squared. So 4 pi times 49. I'm going to multiply 4 times 49, and I get 196 pi units squared. For the volume formula, 4/3 pi 7 cubed. 7 cubed is 343. So I'm going to multiply that by the 4/3 pi. Now, 3 will not go into 343 evenly, so I'm just going to multiply. So I'm going to multiply 4 times 343, and I get 1,372 over 3 pi, and these are units to the third power. So left in terms of pi, you would leave it like that. We could divide, we probably wouldn't divide it, 372 divided by 3, because we'd end up with getting 457 and 1/3 pi units cubed. So I would just leave it like that over 3. Now, for the next one, they're actually giving me what the volume is already calculated. So I'm going to do 4/3. So I'm doing this one now. 4/3 pi radius cubed equals 32,000 pi over 3. I need to solve for the radius. Now, I could go about doing this several different ways. First thing I would probably do is get rid of the fraction. So I'm going to multiply both sides by 3. Cancels the 3's on both sides. So now I'm left with 4 pi r cubed equals 32,000 pi. Next thing I'm going to do is divide both sides by pi. And it cancels the pi's on both sides. Then I'm left with 4r cubed equals 32,000. Divide by 4, and r cubed equals 8,000. Now, most of the scientific calculators do not have a cube root. Some of the graphing do. So what you would have to do is figure out what number times itself 3 times when you cube root this gives you 8,000. And that's going to end up being 20. Now, what you could do is you could do a factor tree for this. 8 times 1,000 break this down, 2 and 4. This would be 10 times 100. And then 2, 2, 2, 10, 10, 10. So this time, instead of making groups of 2, you make groups of 3. So I have 3 2s, so a 2 comes out. You have 3 10s, a 10 comes out. 2 times 10 is 20. So that's how you would do it if you weren't using a calculator. So the radius for this problem, now all of that, it was kind of lengthy. We're going to come over here. My radius is going to be 20. My diameter, double it, it's 40. And now to get the area, remember area is 4 pi r squared. Now that I know the radius is 20, I can square it, get 400, multiply 4 times 400, get 1600 pi. So the area is 1,600 pi units squared. That one was a little lengthy because we had to work backwards. Same thing's going to happen on number 4. So let me go ahead and do the work down here. So they gave us the area. And again, remember, it's 4 pi r squared. So I'm going to do 4 pi r squared equals the 12 pi. And now I need to try to solve for r. First thing I'm going to do is divide by pi. They both cancel. I'm now left with 4r squared equals 12. Divide by 4. R squared equals 3. Square root both sides, and r equals the square root of 3. Normally I would get plus and minus 3, but I don't want a negative radius, so I'm just going to leave the radius to be square root of 3. So I can fill that into my chart. I'm going to double it, so 2 times the square root of 3 just gives me 2 radical 3 for the diameter. All right, next I need to calculate the volume. So next, I'm going to come here. My volume formula, 4/3 pi times radius cubed. My radius is the square root of 3. I have to cube that. So what I'm doing here is square root of 3, square root of 3, square root of 3. I'm multiplying these. Now, whenever you get a pair, this becomes just 3, and then this 3 stays underneath. The other thing you could do is multiply this, get square root 27, and then you still got to go back and break it down. And then 3 and 3, which is really what you started with, pair of 3s, it comes out, and then there's that. So now I have 4/3 pi times 3 radical 3. I can simplify this 3 with this 3, and then my final answer is 4 pi radical 3. And these are units to the 3rd power. Now, the order of this doesn't matter. You could have also done 4 square root 3 pi, and then units cubed, either way. So I can fill that in the box. So I have 4 pi square root 3 units cubed. Now, the next one, it's really all we're doing is filling in the formula. So to turn a radius into a diameter, times it by 2. And then here, my radius is r, so it's just 4 pi r squared. And then same thing for the volume, 4/3 pi radius cubed. Because again, your radius is r. So really you're just putting that in there for the r. Now the other one is backwards. So in order for number 6 to turn a radius into a diameter, we're going to double it. For r. So now let's do the formula. Let me come over here to the side. All right, so my radius is 2r. Remember your formula for area is 4 pi r squared. So I'm going to put 2r in here. So 4 pi 4r squared. So I'll multiply the 4's and I end up with 16 pi r squared. So that's 16 pi r squared. And again, these are units to the second power. Next, I'll do the volume. Volume again, 4/3 pi r cubed, 4/3 pi, and then I'm going to take 2r and cube it. Remember, you're cubing the 2 and the r, so 2 to the 3rd power is 8. Radius cubed, 4/3. Let me rewrite that. Now, I can't simplify 8 and 3, so I'm just going to multiply. 4 times 8 is 32 pi r cubed over 3. So let me go up to the chart and I'll fill that in. So this is 32 pi r cubed over 3. Now, it wants me to compare the areas of 5 and 6. So for number 7, the area for number 5 was 4 pi radius squared, and the area for 6 was 16 pi radius squared. So notice you can either think of it as we just timesed it by 4 to get that, or we squared the first area. We're going to see more of this, how we compare the similar solids, in lesson 9. Then for number 8, they want us to compare the volumes. So the volume for the first one was 4/3 pi r cubed, and then this one was 32 pi radius cubed over 3. So this one was times by 8. So you had to figure out what happened from here to here. But we're going to see more practice of this coming up in 11-9. Let's try example 2. Okay, so for this one, it says that the number of square centimeters in the area of a sphere is the same as the number of cubic centimeters in the volume of a sphere. Find the radius. So what this is telling me is the area and the volume are equal. So area equals volume here. So I'm going to set the two equations equal to each other. So 4 pi r squared equals 4/3 pi radius cubed. I need to solve for r. So the first thing I'm going to do is get rid of the fraction. So I'm going to multiply both sides by 3. And I get 12 pi radius squared equals 4 pi radius cubed. Next thing I'm going to do is divide both sides. I'm going to do this together. I'm going to divide both sides by 4 pi. This cancels. I'm left with radius cubed here. Pi's cancel, and then 12 divided by 4 gives me 3r squared. I still need to solve for r, so I'm going to divide both sides by r squared. This cancels. Remember, when you have exponents, you subtract them, or you could think of this as r over r. Cancels, cancels, and you're left with the radius is equal to 3. Our last example is a word problem. And it says a solid consists of a hemisphere of radius of 1 meter on top of a cone with the same radius and a height of 5 meters. So really this is going to look like an ice cream cone. So let me go ahead and draw it. So here's my cone. And then on top of it, I've got a hemisphere. And it said that it had a radius of 1, and the height of the cone, it said it was 5. So what I need to do is find the volume of the cone, add it to the volume of half of the sphere or the hemisphere. So what I'm going to do is remember the volume of the cone formula is 1/3 pi r squared height. And then for my volume of my sphere, or half of my sphere, I'm going to multiply 1/2 times the 4/3 pi radius cubed. So I'm going to plug in my numbers and then add them. So we'll do this one first. So 1/3 pi, the radius is 1, the height of the cone, remember because it says it's 5. So 1/3 pi, 1 squared is 1 times 5 is 5. I'll multiply this and I get 5/3 pi. For my sphere, 1/2 times 4/3 times pi. My radius is 1. 1 to the 3rd power is 1. So I'm going to add these. So I get 4/6 times pi. I could reduce this and make it 2/3. And this gives me 7/3 pi and these are meters cubed. Pretty good on that? Yes.
Didn't you have to multiply it by a half?
I did. Over here, I did 1/2 times 4/3, and I made it 4/6.
Oh, okay. Thank you.
Uh-huh.
Miss Corey,
Yes.
how did you get 2/3 when you added 5/3 pi plus 2/3 pi?
Because I reduced 4/6 to 2/3.
Oh, okay.
So I reduced 4/6 and made it 2/3 because I needed to find a common denominator. And if I reduced it, then it had the same denominator. It had a denominator of 3.
Thank
Everybody good on that? Okay, so these are the notes for 11-8. Your homework is to do 11-8. It's due before class starts, so it's due before 8 a.m. on Wednesday. When I see you on Wednesday, we're going to go, while you're waiting for everyone to join the Zoom call, you're going to be doing the warm-up for 11-8. And then you're going to also turn that in once you complete it before the Zoom call ends. So if you want to do it while you're doing the 11-8 homework, you can, but it'll be due on Wednesday before the Zoom call ends, along with the 11-9 notes. I'm going to teach 11-9 during the Zoom call, in addition to go over the 11-8 homework. Anyone have any questions?
Miss Corey?
Yes.
Sorry, can you go back to the second slide? I